Welcome everyone to this session, CodeDroidAI, AI code generation for Delphi. I am Eli M. with FMXExpress.com. Been a developer for over 26 years, delivering content and technology that has reached over 250 million people worldwide, including 4 million developers. I'm also the webmaster of FMXExpress.com. This is a LearnDelphi.org Coding Bootcamp 2023. Learn to program. So be sure to check out all the other sessions during the event, and then afterward, if you're watching this as a replay, check all the other sessions over on YouTube. Our agenda for today: what is CodeDroidAI? What are large language models, or LLMs? The code generation functionality that's built into CodeDroidAI includes things like generate procedures, code analysis, comment code, generate forms, convert Delphi code to InlineAssembly, optimize code, and then translate between programming languages. So it offers AI-based code generation and local code generation using things like Docker and the models from Replicane.com. So the functionality that is built into it, you have OpenAI.com's GPT 3.5 and GPT-4 via API. You have OpenLLMs hosted on Replicate.com, and then the OpenLLMs you can host locally using Docker. It has a code verification loop, and you can build your own templates to do things like the generate procedures, but you can customize it with your own code. Okay, let's get started and jump right in. So what is CodeDroidAI? It is a desktop client, it's open source, and it's been designed for Delphi. It has a powerful user interface for code and form generation. It also has code verification. The code verification compiles and verifies Delphi code. It easily reports errors back to the LLM that are found in the code. The large language model support that's built into it includes a broad range of API-based large language models and open large language models you can even host locally. It has a flexible template system. The built-in functionality allows you to be customized, and you can add your own code generation templates. And this is mainly using the prompts. You can customize your prompts, write your own prompts, add your own code examples, all that kind of stuff. So what are large language models? The definition of large language models is a type of artificial intelligence model. It focuses on understanding, generating, and manipulating human language. Training. Utilize vast amounts of text data. It can generate coherent, contextually relevant sentences based on recognized patterns. The size and capability of language models. They're often comprised of billions of parameters, and you'll see that when you see 70B or 13B or 7B, that stands for billions of parameters usually in the model. And it stores immense amounts of information and linguistic nuances. Applications for large language models include natural language processing, chatbots, code generation, content generation, and more. Some examples of large language models include GPT 3.5 Turbo 16K, GPT-4 Vicuna 13B, GPT-4 All, Falcon 40B Instruct, Llama 70B version 2 chat, Llama 13B version 2 chat, Free Willy 2, and Faster Vicuna 13B. So those models are available on both OpenAI, and some of them then are available on Replicate.com. So what is the code generation that's offered through CodeDroidAI? So it has templates that allow you to generate procedures. It has templates for code analysis, code commenting, for generating Fmx form, for converting Delphi code to Borland C++ code, for upgrading Delphi ANSI code to Unicode, for generating a VCO form, for converting a VCO form to Fmx, for converting free Pascal code to Delphi code, for converting Delphi code to InlineAssembly, and optimizing code, and finally translating between programming languages or whatever other templates you'd like to add, and you can customize the prompts yourself. So what is OpenAI's GPT 3.5 and GPT-4? They are two powerful language models from OpenAI. They're only available via an API or a ChatGPT interface. It seems to provide the best code output at the moment, which is mid-2023. Code is shared with OpenAI, so it's not private like a local model would be. Be aware of that when using it for proprietary code. So this is the OpenAI.com interface where you can get their examples and their API reference and your API keys. So that's platform.openai.com. And so if you go to platform.openai.com/account/API API-keys, you can generate your secret key, which you'll need within the CodeDroidAI interface. So then let's talk about the large language models that are hosted on Replicate.com. There's multiple open language models hosted there, and they're available via an API or via a Docker container that you could run locally. Code generation on open models is improving quickly. So everybody's working on this to try to get better models, create new models and stuff like that that are open and allow you to run them locally on your own machines. Code is shared with Replicate.com for hosted models, but not on the local Docker versions of the model. So when you run the local Docker versions and you have your own GPU, then the code doesn't leave your machine. It just goes to the local model and then comes back to CodeDroidAI. So what is Replicate.com? They say that machine learning doesn't have to be so hard. Run models in the cloud at scale. And so they have thousands of models ready to use. Their community of machine learning hackers have shared thousands of models that you can run. So they have language models to understand and generate text. They have streaming language models that support streaming responses. And they have trainable language models, which is something that they recently added, that would allow you to fine-tune using Replicate's training API. And so you can get to all of this at replicate.com/explore. You can also get your replicate.com API key, which you will need within the CodeDroidAI application. So you can get that at replicate.com/account/API-tokens. So you grab that API key and you put it into the CodeDroidAI app, and then you can use the open models that are available through the drop-down interface. So can Replicate.com run large language models like Llama 2 and Vicuna? Yeah, the answer is yes. Basically, these are the three of the models language models that they offer, and you can run them through Replicate.com using CodeDroidAI. And here is the sample code that they show you how to run a curl request on the command line to do a prediction using a large language model on Replicate.com. And then this is the code that shows you how to do it via Docker. So if you want to keep your proprietary code private, you can grab the Docker image from Replicate.com. You have to have a GPU that is able to run this thing, and then your CodeDroidAI could be connected to the local instance via the same API call. So the API call would kind of be the same, but you'd have to customize the URL that it goes to for it. And so here's the Docker command. You can see it's pretty easy. It says use all your GPUs, grab the Docker container here for Vicuna 13B, for example, and then they show a curl example of how to make that call. So what is the code verification loop that's built into CodeDroidAI? So the code verification loop utilizes MS Build to compile the code generated by the large language model using the Delphi compiler. The prompt asks for the code to be returned in a console application, but that isn't always the case. It may have to be tweaked manually before trying to verify it. So the prompt asks the language model to return basically a program name and then some code, and then at the end it says end dot. So it doesn't always do that, and so you might have to tweak that before you try to verify the code. And so the results from the compilation step can be fed back into the large language model to ask it to fix the errors. And that's kind of the time savings part of having the code verification loop within CodeDroidAI. The tight feedback loop of the code verification process can provide faster iteration through the code. So you can also build your own templates. So I use the same template system to build the templates that you see they're available in CodeDroidAI. You can create your own templates by customizing the emoji, the icon there, the title, the description, the prompt, and the prompt hint. The more code examples you can provide in the prompt, the better code generation may work. Now, one thing to keep in mind is that the language models will only take so many words. So I think the original GPT 3.5 Turbo only takes 4,000 tokens, and a token doesn't exactly equal a word. So it could be less than that. It could be less words than that. So that's not very much, and I think that's supposed to contain the prompt and the response. So 4,000, it's not. Anyway, it's not very much. And so the GPT 3.5 Turbo actually supports 16,000, which is quite a bit larger. And then if you have access to the GPT-4 API, it has a 32,000 token model that you can use, which is even larger. And so what that would allow you to do is A, generate a longer response, and B, provide more of an example in your prompt itself. So here is a link roundup that you need to know about. So this is CodeDroidAI. Here's the repo for it. On GitHub, it's github.com, Fmx Express, CodeDroidAI. Here is the link to Replicate.com, the Replicate API reference. That's for curl basically, but you can easily use that and send your code, add your code to Delphi using that. This is the link to the OpenAI.com API keys and their API reference. You can find other Fmx Express AI repos at that URL. And then finally, if you don't have the latest version of RAD Studio, which is Delphi and C++ Builder, you can get it at this link. So let's tab out of our presentation at the moment and click over to some of these links. So this is my repository where you can see all the different projects here, including CodeDroidAI. And you can go there and you can review the code, you can download it, and stuff like that. It has all the description and all that kind of stuff. And so here's the dashboard for Replicate. We can click over here to explore, which we looked at in our presentation. And you can see they've got the stable diffusion models. They have Llama here. They have video generation models, all kinds of different models. And they do audio generation, control net, diffusion models, all kinds of different stuff here. And then you can easily plug this stuff into Delphi. It's so easy to use these. Over here we have the keys, and you can see here this is where you create a new secret key. And this is the API reference for Replicate.com. And so you can see that it has curl examples for all this different stuff. And finally, here is where you can download the Embarcadero RAD Studio Delphi free trial if you don't have the latest version. So now that we've done all that, we can click over to Delphi and play around in CodeDroidAI. So I've already got the project loaded up into the IDE. And so one thing I would like let's compile it first. And then I'm going to show you, you've got this. So this drop down has the different language models there that you can select. So this is an OpenAI one. And then if we move down here, we could pick Llama 2, which would be on Replicate. So I've got my API keys here, I've got my Replicate one here, and I've got my OpenAI one right there. So we're going to go back here because I want to show you where you can configure that. So you can go here, this is a FTFD mem table, and you can right click that. This is right in the IDE, and you can do edit dataset. And so let's make this bigger. And so you can see here's the dataset right here, and I can edit this right here. I could type in B. And it would make that change right there, and then you could recompile the application and it would show up. So let's remove that B. So you've got the language model name, and then on Replicate.com you have this version or model number. And so OpenAI doesn't have that, so this is an OpenAI model, and so we just have the same name again. But for Replicate we have the version number, and it's going to use that version number to request that model on Replicate.com. And then finally you have a provider here over here, so you can see if it's an OpenAI provider or it's a Replicate provider. And there's some code in there that says, hey, is it Replicate provider? Then do one thing. Is it OpenAI? Do another thing. So I wanted to show you that. So when you can add your own models easily when a new model comes out on Replicate, or if OpenAI updates their models and you want to go add that name, you can just go grab that name and plug it in there really easily. So let's load this up. And we're going to go over here. I'm going to delete this right here so it can start again. Go over here to code. So these are the different options that I have, templates that I have built in: generate procedures, code analysis, code commenting, generate Fmx form, convert Delphi code to Borland C++, upgrade Delphi ANSI code to Unicode, generate VCO form, convert VCO form to Fmx, convert free Pascal code to Delphi, convert Delphi code to InlineAssembly, optimize code, and translate between programming languages. So let's click on the first one, and we're gonna hide this. And so we're just gonna use the GPT 3.5 Turbo 16K. So I like using the 16K because it gives you a larger output and larger input if you need it. So up here in the prompt, let's walk through this prompt for a little bit. So the template is where this prompt is defined. And so here's the prompt: you are the best and most experienced 10x programmer in all programming languages. So this used to work really well in the Chat GPT interface, but I feel like they've customized it recently. So now it says, oh, well, thanks for the compliment. So does it really do what it's supposed to be doing? I don't know, but we're still using it at the moment. And then let's talk about the rest of the prompt. Create a new input language procedure that does prompt. Never explain the code. Output should be the syntax that starts with the program at the top and ends with end period. Do not include 3 quote things. So when you use the Chat GPT interface, it uses the 3 quote things as a delimiter to show code, and we don't really want it to do that, so that's why I have that in there. And so then I provide, here's an example procedure using the object Pascal syntax. And so, because I want the language model to know, hey, this is how you write an object Pascal procedure. And then I also provide, here's an example of a function syntax. And so if you wanted to add your own code, you say, here's an example of how to do a REST API call. Here's an example of how to do whatever it is you want it to do. And then that would kind of tell the model, hey, this is kind of the format that I want it to be in. So here we're going to write have it generate a procedure here. And so we're going to write a procedure to load a text file into a t-string list. And be sure to note that a t-string list has a load from file procedure. So I did this without this second part, and it used a file stream or something. So I'm adding this in here so that when it generates this, it actually gives me what I want and doesn't use a T file stream or something like that. So here we go. This is the code that is generated. You've got program here at the top, which I talked about. I wanted to write that so that it creates a console application that it will run through the code verification step. It's got a uses clause here. This is kind of a useless procedure, but this is what it built. It has it loading from file, and here's the t-string list, and it does a create, and it runs this procedure from this file, and then finally it frees it up. So we have this code verify button. We're going to verify the code, and so this compiled the code. We can see that over here. It detects the projects that are available, and then it compiles the code, and so here's the response: code complete. So there were no errors, so this code compiled successfully. So that's really the only verification it does. It doesn't verify that the code works how you want it to work. That's your job, right? But we want to know that the code is actually syntactically correct. So that's what that step is doing. We can look through the settings a little bit. Here is the build command, the ms build, that does the compile. And so I brought this in from another parallel compiling application that I built. So that's why it has this CPU stuff. And it runs this batch file first to prepare the command line to do this compile. And then you can also select the platform. So this scans the directory for the project file, and that's how it brings up that project file. So we're going to switch over here to the second RAD Studio here. And so what I have this console program. This is kind of a template for it to use. And this is a default console application, but the important part is this dproj file. So the dproj file already exists, and all we do is we take the code, we just take this code, we save it to the console program.dpr file, and then that's the file that gets compiled. So in CodeDroidAI, you have this history function. So it has all of the previous things that you asked the language model, and so you can click between those, and it will take you back. It will reload up that data. It will load up that prompt, I believe, and then it loads up the response, and it loads up your question as well. And so there's also a refine code button. So if there was an error in your code, you could say, hey, go fix your error. So maybe we can try to do that. Let's do an error. Let's change this, and we'll do verify code. So in theory, this is not going to compile. All right, so we got some errors. It says, hey, undeclared identifier string list, missing operator or semicolon. So we'll see what happens here. I'm going to do refine output code. So what this does is it takes this error list, and it takes this code, and maybe it takes these, and it sends it back to the large language model and says, hey, fix these problems, please. So we're going to send that back. And then, so you can also see down here, this is the list of tokens. So the prompt token, so this plus this is 192 tokens. And then the completion tokens, which I assume would be this, and maybe that even this, and this is 192. Then the completion tokens is about 100 tokens, according to this response. And so the total tokens for this entire process was 292 tokens. So, and this model can take up to 16,000. So on the smaller model, which I believe, maybe I don't even have that one in there. No, here it is. So this model right here only takes about 4,000. So you got to keep that in mind. Like if you plug in a giant example, it's just going to blow up and say, hey, it's not going to work out for you. So, and this is the response that it got me based on these errors. And you can see that I had deleted that T and created these errors, and it brought back the response and fixed it. And then I'm going to verify code, and then it successfully compiled this time. So that's kind of how all that works. I've got a clear button here and a clear button here to clear all that out, and I also have a clear button for the errors, and then I have a copy button. So once you had the code here that worked, then you could just hit copy and you go paste that in your IDE. Same with this, you can copy that. So we could pick another one. Well, okay, so let's go over the history, and let's back up to one of these histories. So let's take this code, and then we're going to go over here to this template. We're going to go over to this template. So this loaded up a new template. So it changed we're going to delete this, we're going to delete this, and it says, you are the best, most experienced 10x developer and programmer in all programming languages. Return the same response back to me as I give it to you, but add code comments to the following input language code. So this is the input language, and this is the output language. Here is describing what it does, and then here's the prompt, which is what we go here. So I'm going to take the code that it wrote, I'm going to plug that in here. Maybe I'll delete this comment that's got. And then it shows the example for the large language model file. It says this is a code comment on this procedure. This is a multi-line comment. And so that's the prompt content. So we're going to click here, we're going to do generate. And so that actually went to the OpenAI API call, and then it returned this response. So it added these comments. This Delphi object Pascal program loads the contents of a text file into a string list. And then this procedure loads the contents of a file specified by file name into a T-string list. And down here it added some more comments calling the load file into T-string list procedure with the file name and etc. And then finally it added a comment here at the bottom. This code statement creates a string list called etc. So all those were comments. So basically it commented the code that I passed to it. So, okay, so I'm going to go ahead and delete this. I'm going to go back over here. Let's do a code analysis. So I selected code analysis, and this is the prompt. You are the best and most experienced 10x developer and programmer in all programming languages. Describe what the following code does. Prompt. And so these two percentages, that's just used kind of as a delimiter. Say, hey, replace this with the prompt. So when the code, it just grabs this prompt, and it grabs this code, and it plugs it in where this is set up. So, and then I've got here, I have my procedure that it generated. I'm going to go ahead and click generate. And I'm going to ask, basically it's asking it to do a code analysis of what this code is. And so here's the description that it came up with. The code you provided is a simple Pascal program that loads the concept of a text file into a string list. It starts by declaring the necessary units, sysutils, and classes needed for this program. Next, there is a procedure called load file into string list, which takes two parameters, file name, the name of the text file to be loaded, and strings, the string list where the file contents will be stored. Inside the procedure, the load from file method of the strings object is used to load the content of the specified file into the string list. In the main program flow, a variable file content of type tStringlist is declared and utilized by creating a new instance of the tStringlist class. Then the load file into string list procedure is invoked to pass in the name of the text file, filename.txt, and the file content string list. Finally, the program ensures that the proper cleanup by free memory occupied by the file content string list using the free method. In summary, this code loads the content of a text file, filename.txt, into a string list file content by utilizing the load from file method. So that was good, pretty good. So you could take it and you could plug in a Delphi demo into this thing and ask it to tell you what the demo code actually does. So that's pretty cool from my perspective. You can have it generate an Fmx form. So let's go ahead and click that. I'm going to clear these out and then let's see what we can do. So here's our prompt. You are the best and most experienced 10x developer and programmer in all programming languages. Do not include the 3 quotes thing. Create a responsive Delphi FireMonkey Fmx form in the DFM file format. Use the align properties to make it responsive. It should be based on the following description. And then this is the prompt which we're going to pull in from here. Here is an example of the format. So I have the format here from a DFM, or I guess it's an Fmx file, which is in the DFM format, I assume. And this is the text-based format versus the binary format. So you can see object form, left top, the various properties of the form. It has a button in the example, and that's it. So let's see, what do we want it to do? And then I have this hint here, enter a description of what the form should do, and maybe even what controls you want it to use, and the AI will attempt to generate the form in the textual Fmx form format. Okay, so what do we want this to do? Let's say create a t-edit and a t-memo with the t-edit aligned to the top and the t-memo aligned to the client. And then we'll see what that does. Now, I haven't really run these templates since I built this a few weeks ago, so I have no idea what these are going to do. Okay, so here we go. So it created a t-edit, and it aligned to the top, and it created a memo, and it aligned to the client. Now, I think you can actually just, if this didn't have the form code here, you could actually grab this code, and you could copy and paste that into the IDE. But mainly I wanted this code to generate a form itself, so that's why it does all of that. Okay, so that's what the form generator does. Let's clear those out. And the next one, convert Delphi code to Borland C++. So let's click over here, and maybe what we do is we grab one of these, grab this. We'll grab this, and we'll go over here and we'll click this again. We'll clear these out. We'll plug this in. Okay, so what it wants me to do is enter some code that is in the Delphi object Pascal to have AI attempt to convert it to Borland C++ for use in C++ Builder. So here's the prompt. You are the best and most experienced 10x programmer in all programming languages. Do not use the 3 quote thing. Translate the following input language. So that would be Delphi object Pascal, code snippet to Borland C++ code. And then plug in the prompt variable. Here's an example Delphi object Pascal function syntax. And so here's an example of the syntax. And then here is example in C++. So that's kind of what I wanted to do, is do something similar to that. So I don't see that it uses the output language, but I could select the output language here, C++, just for fun. And maybe we can use that later to have it compile that code. But compiling C++ in theory is supported because it uses MS Build, but in practice it's not really supported to do that at the moment. We could add that though, or someone that's more into C++, they wanted that functionality, they could add that. So here's the code that it generated. It generated us some C++ code. It created this here. And here is the main function. So there is it converting Delphi code to C++. How well that worked, I'm not quite sure. Again, we could get this verify code hooked up in the C++ Builder's compiler. At the moment, it's kind of half supported because it uses MS Build, but I don't have it 100% set up yet. This open source project, you can commit it. You can commit some code if you want to get that set up. Or you can just go grab this without doing the verify code and just plug it directly into C++ Builder. Okay, so what else can it do? So let's click over to upgrade Delphi ANSI code to Unicode. Now, this is kind of a complex topic and probably needs more examples added to the prompt, but let's investigate the prompt here and see what happens. You are the best and most experienced 10x programmer in all programming language. Do not include the 3 quote thing. Translate the following input language code. So the input language would be Delphi object Pascal. code snippet, which is from an older version of Delphi and uses ANSI to output language. So let's switch this back to Delphi Object Pascal code, which is the latest version of Delphi and supports Unicode. And then here's the prompt. And the hint says, enter some code from an older version of Delphi that is using ANSI, and the AI will attempt to upgrade and convert it to the latest version of the Unicode support. So I have this other text in here to try to help it guide the large language model to do what we want. When migrating an existing application to Unicode, consider the following: string and character sizes, using ANSI string as a fallback, string conversions, character sets and pointers like p ANSI character, buffer and pointer operations handling external data, external libraries and third-party components, database issues, and then here is some sample ANSI code. So if here's some sample ANSI code, I don't really have any of that code handy right now, but maybe I can grab that. Maybe I can grab that to do the example with. Let's do procedure, fill, make, maybe fill, buffer, and then plug that in, and then end. And maybe we'll be able to do something with that. I assume because I'm also passing this is the Unicode aware code as my response. I assume it's just going to try to pass this because I gave it the question and the answer. So let's hit generate and see what happens. Okay, so if we go down here to the example, it kind of did that. It just kind of returned the response. So if you really happen to have an old application, and I don't really have any of that code handy right now, we converted the dev C++ IDE, Delphi C++ IDE, and it had some of this old ANSI code in it, but I don't really have that code handy right now. So that's how that template would work. And let's switch back, and so you can see here's the tokens down here at the bottom, and we can switch back here, generate a VCO form. So we did generate an Fmx form and then generate a VCO form, very similar, except the formats are different. The properties of the controls are different. So you can see here's some of the different properties. Create a responsive Delphi VCO form, align properties, etc. Very similar to the Fmx prompt that we already tried. And then it's got the button. So let's create a form. Create a form with a T button at the bottom, aligned to the bottom, and a T memo aligned to the client of the form. Again, these are all using GPT 3.5 Turbo 16K. If you have access to the GPT-4 API, you'll probably get better responses even than this is doing. So we're going to click generate and have it generate that VCO form format. Okay, so this is a good example here because what it did is it didn't really follow what I wanted it to do. You can see that it outputted some commentary, which we don't want, and then it outputted the three quotes, which I asked it not to do. So in this case, it got a little confused, and maybe this prompt needs some work. And we could do that. So okay, so let's delete what we did. All right, we got that. Use. So what I don't have in that prompt, we could go over here to, maybe if we go back to the original prompt, never explain the code. Maybe we need that here in our generate VCL template. Creative wants to, okay, and never explain the code, use the line properties. Okay, here we go. So I cleared out, I still have my question here, and I have my answer. I cleared out the answer. Let's do generate again. And so I'm not, I don't think this dynamically updates the template when you do this. I'm not sure, we'd have to go back and look at it. Okay, so you can see just this small change made it so that the response is what we want. It is VCO code here. I know that some of these are VCO ones, and so therefore I know that this one is a Delphi VCO form format and not Fmx format. So there you go. That was pretty good. We made a small change to our prompt, and we got the result that we wanted. So let's go over here to the template editor, because why not? And let's see. So we're in the correct one. So if I go here and go boom, I'm going to put that in there, and then I'm going to hit save. I think this is the save button, and then I'm going to go back here. Let's click a different one, and then we'll go over here, and we're going to go back to the VCO form, and you can see, except for that's the convert. Here we go. So you can see the template has been updated using the template editor. So that was pretty good. Let's go back. Let's clear this out. Let's go back to convert a VCO form to Fmx. Okay. So let's try that. We just had this history, so let's load this back up again. Not that one. That was the one that didn't work out. Okay, here we go. So this is a VCO form that it generated, and then we want to convert the VCO form. So now we have the correct prompt in here. We're going to delete this. We're going to delete this. We're going to plug our VCO form into here, and we're going to do generate. And so it's got an example here. Here's an example VCO form format. And then it shows you the same format in Fmx. And so then, okay, so this one kind of did the similar thing where it didn't 100% return the syntax that we wanted. So this is what it returned. So this was interesting because it says, instead of accepting the compliment, it says, oh, I guess I am a 10x programmer, and I will help you to do this. Okay, so we know based on the previous one that what we need is that other code. Here we go. We need this code, and maybe that will solve our issue with it returning responses or commentary, which we don't want. So I'm going to clear this so that I don't want to do a refine. I just want to generate it from scratch again. Okay, there we go. So we converted a VCO form to an Fmx form. And you can see that this is the Fmx format because it has properties and things that the VCL one doesn't support. And it also changed those properties, etc. In this case, so that's interesting. It changed the client height and width to something else, kind of. So anyway, that appears to have worked. And so down here, you can see the tokens. So all of this combined, we had the prompt with its examples, significant example there. And then we have this that we append to the prompt. This is our actual question. And then we have the response. And you can see that all that combined was 785 tokens. But we have up to 16,000 tokens. So we could provide more significant examples and maybe get a more significant response as well. What else do we got? We got convert a free Pascal code to Delphi. So I don't really have any free Pascal code handy, so I'm not going to run that one. But basically the prompt is you're experienced programmer, don't include the three things, and translate the following free Pascal code to output language. So the output language in this case would be Delphi Object Pascal, but in theory you could pick any of these output languages and it would translate that code, or try to anyway. Convert Delphi code to InlineASM. So this could be interesting. We could try a demo with that. So when I've done this in the past, sometimes it says, oh, I'm not an ASM programmer. This is really tricky. So maybe we try this. Let's go to our history. Go to our history, maybe go to the beginning, what we originally did. Grab our original code here. Or I wonder if we can grab where's our commented code? Here we go. This is our commented code. What if we grab our commented code? Maybe that'll help it. Okay, so we're going to go here to our InlineAssembly. We're going to delete these two things. And so the hint says provide code snippet that you want the AI to try and convert in InlineAssembly. This may or may not work depending on the AI's mood. It seems to work consistently in GPT-4. So we're not using GPT-4. I have GPT 3.5 API access, and so that's why I'm using this. And so, okay, let's read the prompt. You're the best programmer. Do not include the three quotes. You know how to write inline assembly code and how to make it secure. You do not make errors. Take the following input language, so Delphi Object Pascal, and convert it to the output language. So, Okay, convert it to output language, so Delphi Object Pascal, inline assembly, and then this is the prompt. And here's an example of inline assembly syntax. So this shows it how to run that syntax, or how to put in inline assembly in Delphi. And maybe this prompt could be better, but let's go ahead and run it and see what happens. But again, you can easily customize this prompt, add more examples, and to get it closer, to generate closer to what you want. So yeah, it didn't really like that. It's like, so it kind of did it, but it's got our 3 quotes, and it's got an explanation here at the top. So it looks like all of these kind of need that thing that I do in some of them. Let's go back. Never explain the code. So it looks like I need to do an update to the repo here and have it never explain the code. Okay, so we're going to go in here. You never explain the code. And then we're going to clear this out because I don't really want to do a refine. But you can see that it did actually try. It did put in the inline assembly, and it did write some code there. So we're going to clear this out and do generate and see if we can get a better version of this. Okay, so yeah, it didn't really do, I think maybe that's why I don't have the never explain the code, because it did not do what we asked it for. It didn't create any assembly. We take that out though, and we do clear this out and generate again. But I feel like you could add more syntax. So it's, again, it tried to do some assembly here. Did that actually work? I don't think so. But this is also GPT 3.5. GPT 4 actually works much better with the assembly. Though, as I said before, it does its thing where it's like, oh, I don't really know assembly. This is hard. Okay, so moving on. I just have that template in there because it feels like it could be fun to use. So optimize code. So that could be interesting because we have this code here which is not really optimized. So let's clear this out and then read our prompt. You are the best and most experienced 10x programmer in all programming languages. Do not include the triple prompt thing, or triple quotes. Optimize the following Delphi Object Pascal code for execution speed, code readability, and code brevity. And here's the prompt. Okay, let's see what that does. So we're going to go ahead and run that. And we'll do our, so here's the token count, 443. And so here we go. This is what it did. It was like, you know what? I didn't really need that extra procedure at all. I just needed to do load from file. So it optimized the code that it originally wrote. And of course, it gave me commentary, which I'm kind of okay with on this one because it explains what it did to optimize the code. And so all right, we're going to go ahead and delete this. I'll show you an example of doing that. So we're going to delete all this stuff outside because I don't really need that. And then we're going to do a verify code and see if this code compiles. Boom, there it is. So the code compiled. There you can see complete. And there it is. It optimized this function into this function and remove this unnecessary procedure. What else? What other templates we got here? Translate between languages. Okay, so let's clear this out. Let's read our prompt. You are the best and most experienced 10x programmer, blah, 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 in the programming language. Translate the input code, Delphi Object Pascal, code snippet to the output code. Okay, let's see. Let's try to translate it to Python. Output should be the syntax that starts with program at the top and ends with end. So this one probably needs some help in this prompt here because that output is not going to work out for Python. We're going to delete that, and then it says do not include the triple quotes, and then it gives an example, translate from the JavaScript to Python. So here's JavaScript code, Python code, and then input code, the prompt, and the output code. Okay, so again, this prompt probably needs some more help, but let's see what happens. Okay, so it created this class. Looks like it opens a file, and maybe this works, maybe it doesn't. I have no idea. I'm not a Python programmer. It looks like it gave you the structure at least, if that doesn't 100% work. And so it'd also be nice to go in and, since this is an open source project, go in and have it do a verify code on Python. We could easily add that functionality in here. They would just say, hey, this is some Python code. Go in here and detect it's a PY file and run Python against it, and then bring the errors into this box. Okay, so we've moved through all the templates. I'd like to get some more templates in here and maybe optimize a few of these that aren't up to snuff yet. But you can see this was the interface that we used. There's an auto one, so that every time you generate code, you would be able to automatically verify it. So just to reduce that feedback loop. So there's the history navigation. And so you can see it has the date, the prompt, input language, input text, and the output language. And finally, we have the template editor. So I showed this already a little bit, how we modified a template. But you can go in here and you can add your own templates, plug in your own prompt, plug in your hint, a description, emoji, and then an ID. Here's the ID over here, 10. So you just do plus, or you can delete some of the templates. And then I think you would reload the application. I'm not sure 100% auto reloads. But if you reload the application, it would reload those templates, and you'd have all of your templates in there. Okay, so now let's close that out. Go over here to the IDE. And maybe we mess around in the IDE here a little bit and see how the application is built. So here is the frame. So you can see this is our frame. And so we can click here and edit it, and then this frame just gets loaded up into the IDE, and those fields get replaced with the data from the table. So here's the template mem table. So there's a FT mem table. You can edit this right in the IDE. For me, this is really a time-saving thing. I can just it's a little bit. It could use some help on usability, but it is pretty cool that you can just go edit this data and it's right there in your application. And then you could compile this as Mac, you could compile it to Android, whatever, and you just plugged in this data all within the IDE. So here's the various fields for the templates. That's pretty easy. Here's the emoji. Let's see, what else? So these are the REST components. And so all these REST components, I just use the REST debugger. You just plug in the URL. So this might be, this is not the real URL, but replicate.com, prediction, and then you would put in your code. This would do a post. This would do a JSON. You'd add a parameter. You'd add in your header, and it would be authorization, and it might be bearer, and then your Replicate API key, like that. You don't want to encode it, apply. So now that you've got that. And so this is the REST debugger. Again, I got to that from the tools thing. And so then you'd put in your thing. You could put in input. I'm not 100% sure this is accurate for replicate, but prompt, write some code. And then you could get a response here. And so the cool thing about all of this, though, is that once you have a successful REST call working, then you hit copy components, and then you go into the IDE. We can use this one just for testing purposes. Copy components. So see it copied those. And if you've done a request, it'll actually copy the FT mem table as well. And then you go in here. Let's see if I can select. All right. And then you can paste. And now your REST client is automatically set up already to do everything you wanted to do. And all you have to do after that, is go in here and do REST request one.execute. And then you would execute that code right in the IDE. That's how simple it is to create a REST request. You can even do it at design time. You can go here and you can do right click and you can do execute. And if you had an FT mem table, it would load that data up right in the IDE. Okay, so we don't need those. We're going to go back here and maybe we'll walk through the code a little bit. Let's see. So we have some copy to clipboard stuff here that I have on those buttons. I put the clipboard. So here's the Fmx service that does this. Again, this is a cross-platform application. It, in theory, works on Mac, Linux and Windows. It's really set up for Windows. I haven't really compiled it to Mac or Linux before, but it is set up. It is ready to do that. It is ready to do that and test. Restore. It loads up the templates and it loads up those templates into the card interface using the frame. In this case, it's using a buffered layout, which might make it a little bit faster drawing-wise. Am I using Skia? All right, so I'm using Skia on this as well. So this is Skia enabled. I'm using Skia for Delphi in this project, and so all the drawing is provided via Skia. So to load template, this is what loads up the template from the template mem table into all of the fields. Build button. So this is the code that I brought over from my parallel compiler, and so this does a build, goes through and grabs all the things, creates a task, and does a build of the sample project that created to verify the code. This is more of that. This is all the code that it takes to do that build. Let's see, save templates to file, closing the application, creating the application at the beginning. Like these are the events that do that. We've got the history grid. It loads up the data from the grid into the various fields. Let's see, input memo tracking. This handles the hint hiding, and then output memo change. So this has to do with whether it provides you a refine button or not. Process task. This is with the build step to do code verification. Again, more code verification code here, build end. Verify code, so this is just this saves out the code in the output to this console.dpr project, and it's combined with that dproj file. So the dproj file is there, and it just kind of uses that, but it replaces the dpr file with your code from the output. This is scan. This is part of the verification thing. It scans the directory for these dproj file and then compiles it. Let's see. Search. Okay, so that's for opening projects. Clear buttons. This is creating the OpenAI JSON. So actually, I think I had this text written. OpenAI wrote this text right here. So it creates the text. So OpenAI has a couple different things. It has this system prompt, and so that's kind of where I put the "You're the best 10x programmer." And that's really where it's supposed to go. And so then it has this other prompts: role of user and role of assistant. So you can customize this more. That's kind of the chat interface that it provides you access to. And then this is some code that it uses to say, hey, these are the errors. I tried to fix it. I tried to build it. These were the errors. Do something with that. So you can customize all of that if you want. Here's the API key hider, get message content. This loads up. It parses some JSON and gets the content field or value from it. This is a timer to handle that progress bar. Concatenate JSON strings. The response that you get is kind of broken up in an array because it's kind of a chat so you could display the array. And so this just takes all of that and just combines it into a single string. This is the create replicate JSON. So again, I think I wrote this with ChatGPT, and it's got a simpler prompt. But I think now with Llama 2, they have a chat interface, so we can upgrade this now so that it behaves more like the OpenAI one does. This is the generate button. So you can see this is where it picks whether it's the OpenAI provider or the Replicate provider. You could add other providers here. You could add a third provider, say, hey, I'm using Docker, and this is the URL for the Docker stuff. Here's the task here. Again, here's it for the OpenAI side. It does this stuff. It plugs in the API key from the OpenAI. And then it does the output. So this is inside a t-task. And then when we have some code, so it's sitting here waiting inside this t-task for the REST call. And then we have some code here that synchronizes the drawing changes, like editing the text and stuff, back into the main thread. So it does that. And then for the replicate side, very similar. It uses the FDMem table and saves to the history and synchronizes any graphical changes.
On Windows, it does this execute and wait. That's part of the verification step. And that's it, folks. That's all of the code that this CodeDroid AI has. I'm not sure. I don't think there's any code in here. Maybe there was. Yeah, there's just this one. Load the template into the panel. Okay, so let's switch back to our slideshow here. And we're almost done with this session. Switch into the slideshow. So these are some of the other Delphi AI integrations that I built. And so they're kind of all based on the same TREST client and using REST debugger and all that stuff, but they do different stuff. So we've got an AI Translate, which does over 100 language translations, world language translations, so you can translate from English to French using Replicate and OpenAI. You've got the Stable Diffusion desktop client, which does all the different Stable Diffusion models that are hosted on replicate.com for generating images, creating all kinds of different stuff with that, doing upscale, things like that. We've got the ControlNet sketch to image, which lets you draw this sketch using a Delphi Fmx Form, and then it turns it into an image using Stable Diffusion on Replicate. We got text to video desktop client, which asks for a video and it displays the video that it gets generated. We have a Songwriter AI, uses the language models on Replicate and OpenAI, I think. We have an AI playground to play around with different language models. We have an AI code translator, which is very similar to this CodeDroidAI, that one template that I built and added in there, the translate code. That originated from this code, from this AI code translator. We have an auto blogger, which creates this summary, template summary, and then it asks it to write based on the summary that it created or the outline, it asks it to write a blog post around that. We have a text-to-vector desktop client, which uses, I think it's called Illuminate or something like that. It uses that API to take your text and render a vector image, an SVG, which that's pretty cool. Skia supports SVG, and so you can take those vectors and you can paste them right into the IDE, so that's pretty fun. Generative AI prompts, so that helps you generate a prompt using kind of a random generator. And text-to-image prompts, that's another, that's one of the original Stable Diffusion clients that I built. And then finally, we have a Dream Booth client that I built that allows you to take 20 images of yourself and fine-tune Stable Diffusion to put yourself inside of Stable Diffusion and generate images with you inside it. Okay, so that's all the different, you can check all those out on GitHub. And so thank you for attending this session. Thank you for joining us at Coding Bootcamp 2023, Learn to Program. Thanks for watching, and we'll see you in the next session. Thank you.